Hey Geometry, Mr. Florio, 9.3, revisiting rotation. So let's see how we did. Suppose each two-dimensional figure is rotated around the vertical axis shown. Each small square in the group represents 1 square centimeter. Okay. Either sketch or describe in words the three-dimensional solid that it would form. Okay, so if we took this weird-looking shape here and rotated it around the y-axis, or not the y-axis, but this vertical axis, what would it look like? So you're imagining kind of rotating this figure around and around and around and around. What figure would that make? So it's kind of, if you rotated it over here, it's going to come kind of somewhere over here. And you would get kind of this circular shape. And I'm going to draw it down below in a second, but it's going to look something like that. Let's see here. So it's like we have kind of the cylinder on top, but then it gets bigger. Then there's going to be like another bigger cylinder on the bottom. So that's going to look like this. It's going to look something like that, where it's kind of like you have two cylinders on top of each other. And let's see what the other one's going to look like. So sketch or describe in words. It looks like it's two cylinders kind of on top of each other. Let's see if I can make it nice. This one down here, so this one's going to be a little tricky. If I rotated this around in circles around this y-axis, it's going to be a cylinder, but it's going to kind of be hollow on the inside because there's no in-between region here. So if I rotated this around, it would be something like this. And it's being rotated around, so in circles. So imagine this coming kind of through the paper and in, through the paper and in. What would that look like? Something like this. So now there's no space in here, so we're going to kind of cut out a little piece of this. And it looks something like that. So this region right here gets kind of spun around, and there's no inside to it. The inside got kind of cut out. So that's a little bit about what the shape would look like. And I think I can have the books drawn out shape too. Let's see if I can find it. Yeah, so this is how the book drew it. So again, kind of similar, right? We have a cylinder on top of a cylinder, and here we have a cylinder cut out of a cylinder. So let's see. The next question is to find the volume of the solids. Okay, cool. So it said sketch or describe in words. I didn't describe these in words. I just sketched them. But let's see if I can start plugging in some numbers and see how this works out. Let's do orange. So if I wanted to find the volume, I got to find the volume of the two pieces. I'm going to call this like volume 1 and this bottom piece volume 2. So the formula for area of a cylinder is still the area of the base times the height, and the base is a circle, so it's pi r squared times height. So I need the radius, which is going to be this, and I need the height, which is going to be this. And the radius, let's think about this. Going back to this got kind of spun and made the circle kind of up at the top here. All right, because it's going to look something like this. So this is the radius. The radius is 2. The height rate is going to be whatever this is right here. And I'm just counting squares. That's going to be 3. And the height for the bottom piece right here, so this height, I'll call that height 1 and height 2. This height is going to be 1, 2, 3 as well. So it's height 1. And the radius here, so if you haven't already kind of figured it out, if that's the circle, the radius is this guy right here. I'll call that radius 2. That's 1, 2, 3, 4, 5. That's bigger. So radius 1 is 2, and radius 2, the radius down here, is going to be 5. So if I want to find the volume, the total volume, it's going to be the first volume plus the second volume. And the first volume is going to be pi r squared times the height. And the second volume is also going to be pi r squared times the height. And I'm just saying radius 1 and height, radius 1, height 1, and height 2, and radius 2 for the second shape. So r is 2, so it's going to be pi times 2 squared times the height, which is 3. And this radius is 5, so it's going to be pi times 5 squared times the height, which is also 3. Getting a little closer now. 2 squared is 4. 4 times 3 is 12. So it's going to be 12 pi. 5 squared is 25. 25 times 3 is 75. So it's going to be 75 pi. You can put this in your calculator and multiply out the pi. I'm just going to keep it in terms of pi so that the answers stay exact. 75 pi plus 12 pi. That's going to be 87 pi. So right here was 12 pi. Right here, the volume was 87 pi. Altogether, the volume, excuse me, not 87, the 75 pi. So altogether, the volume was 87 pi. So that's the volume of that solid. Let's come here and do this one next. So we got to be a little bit careful here. The total volume is going to be the volume of like the giant cylinder. So we'll say volume, the big volume, minus, we got to subtract out this cylinder. If I take the entire volume, I have too much because there's a hole cut out. I got to subtract out that hole. So I'm going to do the volume, the small of the hole. So the big volume minus the one that we're subtracting out, that hole. So then we need to find the radius and the height of this. Coming back to the top here. Again, the height is going to be this, which is 1, 2, 3, 4, 5, 6. So this is 6. Now the radius of the entire thing, right, when we wrap this around, the radius of the big one is going to be 1, 2, 3, 4, 5. And we got to subtract out the small radius that's also going to get wrapped around, right? Because this is what we're kind of subtracting out of the big one. And this radius is 1, 2, 3. Right? 1, 2, 3. So I'm going to call this capital R because it's the big radius. I'm going to call this little r for the little radius. And that's 3. Okay? And they both have the same height. So the volume that we're looking for is going to be, the big volume is pi times the big radius squared times the height. And we need to subtract that from pi times the little radius squared times the height. So the entire volume minus that little hole that got cut out. So we know the big radius is 5. And the height is 6. The little radius is 3. And the height is still 6. So 5 squared is 25. 25 times 6, I think that's 150. 3 squared is 9. The height is 6. 9 times 6 is 54. So the volume of the whole big cylinder is 150 pi, but we got to subtract out that little cylinder that got taken out, which is 54 pi. 150 minus 54 is 96 pi. Okay. And that's it. So what we just did is just took the volume of composite shapes, and maybe it took a while, but the whole idea is just take the two volumes, add them together, and that'll give me the total volume. And here, if we got kind of like a piece cut out of a shape, then take the two volumes and just subtract the piece that got cut out. Okay. And doing this with rotations, kind of visualizing the 3D images, I think is a challenging part. Kind of drawing it's a little tricky, but it just takes a little bit of practice. And that's it for the lesson, I guess. One kind of thing to mention is, I guess the big idea is that if I want to find the volume of a cylinder or a prism, it's base times height. That's not the volume for every shape in the world, but for cylinders and prisms it is, because you're just kind of taking that volume on the bottom and stacking it up, kind of back up here. Just keep stacking the volumes up. The area of the base, just keep stacking that base up, and that'll give you the volume of the entire shape. If you kind of look at, see if I can find a picture. These few shapes down here, which ones will our volume formulas work for? Let me get a better one. Can I use the volume of the base times the height here? It wouldn't work on this shape because the base here is a big square, but then that square gets smaller and smaller and smaller and smaller and smaller. The cross section gets smaller as you go up. So we would not be able to use that formula on a pyramid. What if I asked you to take the volume of the nut and bolt? This we could do because here we have a cylinder, a kind of a skinny cylinder but long, and a short cylinder but fat. We just need the area, the base, and the height, multiply them together to find the volume. Here, this is like the last example we did where we find the entire volume of the entire shape, base times height, volume of the area of the base times the height, and we just have to subtract out the volume of the cutout piece. And we could find that with our formulas. Same with the pencil. This is just a really long cylinder. We just need to find the area of the base, which is a circle, and multiply it by the height. And maybe it's not a circle. I don't know. Is this pencil? Maybe it's like a hexagon. But whatever the base is, that area times the height will give us the volume. Would a traffic cone work? And no, that won't work either because the base down here is a circle. The circle gets smaller on the way up, so the volume is not going to be multiplied by the base. It's going to be a little bit smaller than that. And we'll figure out maybe later in the lesson how to find a volume of a shape like this. Stick of butter, no problem. That's a rectangular prism. That was one of the first volumes we did. We just need the base, which is rectangle, and multiply that by whatever the height is. Anyways, so that's it for this lesson. Good luck on the homework. Any questions, feel free to send us an email. Thanks. Bye.